The next example we have is a detailed analysis of GIRDER bridge, and well, we are analyzing just the anchorage zone. Here we have some real models, and we try to model what it happened to these real beams. Well, here let's see first the model.
You're seeing how easy it is to perform always a simulation of real models with this software.
Well, this is the concrete part. Is also modeled with solid elements with non-linear behavior. And well, if I hide it, and well, I'm going to plot all the tendons. Here we can see we have tendons inside the tendon cast. So we have two different elements and the tendon cast. What we've done is that for the cast, we have done also we have used the insertion option. So well, if we plot all together, we can see the mesh here also doesn't match, but we did with the tubular section insertion inside the concrete, and then between the tendon and the cast we can have an slippage because it's not connected. We can use contact elements between them or coupling equations. We have used coupling equations in this case also for the compression. Here is the anchor stamp, and for the area to cover the area of the strap here. So the way to make these connections is also here in the mesh. We can use connections. Here we select one node, and that is the master node and the ties node. After selecting it, we give the behavior. Here in our case, I can select model utils, and here we can see the behavior is rigid because I'm completely connected it. But we can select different options. Have a coefficient and a spring and couple it, well, rigid, different options. We can define an equation just to model a certain slippage or something here for more detailed. And then from this other end, I apply the tendon press stress, a force on the tendon here. So I will have here compression and see the behavior of this, and if I need to improve reinforcement. So first here I'm going to load the result. Here, well, the model was solved in 8 steps. I'm plotting the last one. And in example, I'm going to plot stresses. Results for misses equivalent stresses in example and plot them. And most of the stresses, these high stresses, are in the tendons. So just to see the concrete, I'm going to hide the tendons and plot those results again. Well, I can see here in pounds per square inch the compression loads here in this part, and well, we can take the units and plot them in any other unit for well the different sort of units people are used to manage. Here, well, the compression loads. And well, let's see if we can have any cracking problems in my model. So we will also plot here a crack width, component of crack strain, and here we can see some crack patterns here near in both sides, crossing them in this part near the tendons.
Connection of tendons at the
So
end.
well, analyzing this with the results you can find here, we have some lines, some pattern lines similar to what it's here, having here, some others following the others. So well, we can analyze in details the behavior of concrete and improve the designs and in our models.